Hey guys, sorry, let me make it a little bit where you can see it better. Okay, so this is actually purple, but it looks blue. Anyhow, ignore the numbering because this is an older study guide, but I just wanted to talk about the properties of parallelograms, rectangles, rhombuses, squares, and then don't worry about a trapezoid. So this is all in the notes that we took, those 6.7 ones. But for parallelogram, opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. The diagonals bisect each other. And consecutive angles are supplementary. So maybe you want to pause this page and copy everything down. And then for a rectangle, they have all the properties of a parallelogram. So all 5 of these above and 2 add-ons. Diagonals are congruent. And then all the angles are right angles. And for those of us that can picture a rectangle, we know all the angles are right angles. Okay. Describe all the properties of a rhombus. So a rhombus has all the properties of a parallelogram, these 5 up here. It also has all 4 sides congruent, diagonals that are perpendicular, meaning where they intersect is 90 degrees, and the diagonals bisect opposite angles. So those are 2 newbies. And a square is extra, extra special because it has all the properties of a parallelogram, a rhombus, and a square. Okay, so let's move to your study guide now, where we will actually do some problems. So here is number 52. Okay, just want to make sure I'm starting in the right area. All right, and this is bark. It's a parallelogram, and we know the angle A is 99. Yay, angle A is 99. We also know with the properties of a parallelogram that the opposite angles are congruent. So we know that this is 99. So now I know angle K is 99 degrees. And I know that consecutive angles, they're supplementary. So to find angle R and angle B, I'm going to do 180 minus 99. And I'm going to get 81. So I know that this angle is 81. And I know that opposite it, or even consecutive to either of these 2 angles, is also going to be 81 degrees. Okay, so here comes the tricky one, number 53. So we know that this side is equal to x plus 24, all right, AB. We know that AR is equal to 4x plus 15. RK is equal to 3y minus 11. And KB down here is equal to y plus 40. Okay, so we also know the opposite angles of a parallelogram are congruent. But we run into an issue here because when we set these equal to each other, let's say we do y plus 40 equals 4x plus 15, we can't solve it because we have 2 variables. So what we're going to do is we're going to use substitution. We are going to solve for y. So we're going to subtract 40 from both sides, and we're going to end up with y equals 4x minus 25. Okay, so that's y. Well, we can't plug it back into the 2 that we set them equal to. So we're going to plug this y in to this equation, these equations right here. So we have x plus 24, because we know these are equal, equals 3y. But hey, don't I know that y is equal to 4x minus 25? So I'm going to plug that in right there. 4x minus 25 minus 11. Okay, I'm going to distribute, and I'm going to get x plus 24 equals 12x minus 75 minus 11. Kind of simplifying, combine my like terms here, and I'll have x plus 24 equals 12x minus 86. Okay, I'm going to move some things over, and I am going to get 110 equals 11x, and divide and get x equals 10. So here's x equaling 10. Now I'm going to solve for y. So what I'm going to do is I'm going to take what x is, and I'm going to plug it into this equation over here. So y equals 4 times 10, right? Because isn't that what x equals? Minus 25. And I'll have 40 minus 25, and that will give me 15. Okie doke. So moving right along, number 54. Okay, RKG. So I'm going from R down to K over to G. It's 49 degrees. That angle right there. And I have AGR. From A to G to R. This angle right here is 82. They want me to solve for RGK, which is right here, and ABG, which is right here. So I'm going to solve for this angle first because I can see that this angle and this angle are a linear pair. So in order to solve for angle RGK, I'm going to do 180, the measure of a line, right? Because we're talking angles. And I am going to subtract 82. It will give me 98. Okay. My next step is I want to find that angle right there. Well, I know this is 98. I know these are vertical angles, so this is 98. And I know that these angles right here are alternate interior because these are parallel lines. So this is 49 degrees. I also can hopefully see that this is a triangle. So to solve angle ABG, I'm going to do 180, the measure of a triangle. I'm going to subtract 49, and I'm going to subtract 98. When I do that, I will get 33. So I now know that this angle right here is 33 degrees. Okay, moving along, going down to bark, the next bark. AG, which is right here, 4x plus 7. And KG, which is right here, 2x plus 33. Okay, this piece right here and here, they're congruent to each other because this is a parallelogram. Because if you remember, the diagonals, they bisect each other. So because of that, I get to set them equal. Keep in mind, guys, we're working with segments, not angles anymore. So line segments. So I'm going to do 4x plus 7 equals 2x plus 33. All right. I'm going to subtract 2x and subtract 2x, and I'm going to subtract 7 and subtract 7. Get 2x equals 26. So I subtracted 2x here, that canceled out. I subtracted 2x here, that canceled out. And then I subtracted 7 and 7. All right, I'll divide by 2 and divide by 2, and I get x equals 13. Okay, so here's 56. Ooh, okay, this one is going to take a while because it says determine whether the quadrilateral is a parallelogram using the distance formula. So we're going to do the square root of y2 minus y1 squared plus x2 minus x1 squared. All right, first step, I'm going to go ahead and find the sides opposite each other. So if I were to draw a little rectangle, I would do D, E, F, G. So I'm going to find D, E, and F, G first because opposite sides of a parallelogram are congruent. So DE is going to be 6 minus 1 squared plus negative 3 minus negative 8 squared. Well, 6 minus 1 will give me 5. I'll square that. And then two negatives side by side, they become a positive. So I have negative 3 plus 8, which is also going to give me a 5, and I'll square that. Well, that's 25 and 25. And when I add those together, I get rad 50. So I know that D is rad 50. DE. Let's check FG now. So FG. I might be running out of room here. I'm going to have 1 minus 4 squared plus 2 minus 7 squared. Well, 1 minus 4. Oh, oops, I forgot. Negative 1 is going to be negative 5 squared. And 2 minus 7 is going to be negative 5 squared. When I square negative 5, I get 25. Square negative 5 again, I get 25 again. And I get rad 50. So far I know that 2 of my opposite sides are congruent. Let's see if the other 2 are, just to make sure it is a parallelogram. I'm going to start writing a little bit smaller here. I'm going to do EF. So EF, and we'll do the distance formula using 4 minus 6, and I'm getting all the points from right here, guys. 4 minus 6 squared plus 7 minus negative 3 squared. 4 minus 6 is negative 2 squared. And then right here we have 2 negatives, so we make it to a positive. So 7 plus 3 is 10. And we're going to square that. We'll get 4 plus 100, and we'll get rad 104. All right, fingers crossed. Our last one, DG. All right, I'm going to kind of do it down here since I'm running out of room. It's going to be negative 1 minus 1 squared plus 2 minus negative 8 squared. Well, this will be negative 2 squared. You guys are probably already seeing what I'm seeing. Plus, well, 2 negatives side by side make a positive, so this becomes 10 squared. And I end up with 4 plus 100, and that gives me rad 104. So yes, this is a parallelogram. I'll leave it right here if you want to kind of pause it for a sec and get that work done. And move along down to 57. Whoops, or 58. So determine the quadrilateral as a parallelogram using slope. That means we need both pairs of opposite sides to be parallel. Their slopes have to match. So I'm going to start with LM first, which is going to be 9 minus 6 over 5 minus negative 1. Okay, well, 9 minus 6 is 3, and 5 minus negative 1. Well, 2 negatives make a positive, so 3 over 6. I'm not going to reduce it quite yet. All right, and now I'm going to do NP, which is going to be negative 2 minus 2 over negative 8 minus 0. Right, negative 2 minus 2 is negative 4. Negative 8 minus 0 is still negative 8. All right, well, and now it looks like a good time to reduce. So these can reduce. They're both divisible by 4, which makes this become a 2, and this become, which makes this become a 1, and this become a 2. Right, and then a negative here and a negative on the bottom, top and bottom, that cancels out, and this becomes positive 1/2. All right, and then here, they can both go into 3. 3 goes into itself once, and 3 goes into 6 2 times. All right, so LM and P. Let's do MN now, which is going to be 2 minus 9 over 0 minus 5. 2 minus 9 is negative 7. And 0 minus 5 is negative 5. Nothing to reduce there, so we're safe so far. And then we're going to do LP, which is going to be negative 2 minus 6 over negative 8 minus negative 1. All right, negative 2 minus 6 is going to be negative 8. And negative 8 plus 1 is negative 7. Well, that does become a positive 8 over 7, but these aren't parallel or anything really. So no, this is not a parallelogram. Moving down, determine whether the quadrilateral is a parallelogram using the distance and slope formula. So I'm going to do slope first because that gets me halfway to my distance. Okay, so first up, I'm going to find BE. It's going to be negative 7 minus negative 9 over 4 minus negative 2. All right, well, two negatives, that becomes a positive, and we're left with 2. And then two negatives, a positive, over 6. So there's BE. And then we're going to do CD, which is going to be negative 3 minus negative 5 over 6 minus 0, which also is 2 over 6. All right, so far we have one set of parallel. Let's make sure the other set is parallel. Okay, so here's BC. I don't know why I wrote G, BC. And that's going to be negative 5 minus negative 9 over 0 minus negative 2. Okay, so two negatives side by side, positive, negative 5 and positive 9 is simply 4. And 0 plus 2, which is two negatives, become 2. That would just become 2. All right, last one, ED. So negative 7 minus negative 3 over 4 minus 6. All right, these two side by side, positive, negative 7 and 3 gives me a negative 4, and 4 minus 6 gives me a negative 2. Well, two negatives become positive, so positive 4 over 2, and it reduces. So look, those sides are both parallel. Now, just to make super sure, they want us to use the distance formula. So we're going to use BE. And the good news is we've already found the difference, right, of our x and our y. So we're just going to put this number and this number in and square it. So 2 squared plus 6 squared is 4 plus 36, which gives me rad 40. All right, so that's BE. Now let's check out CD, which is across from it. And I look here, and again, I have 2 squared plus 6 squared, which equals 4 plus 36, which equals rad 40. So the opposite sides there are the same distance. Let's check the other set of opposite sides. So BC, we are going to do the square root of 4 squared plus 2 squared, which is going to be 16 plus 4, which will be 20, rad 20. And our last one, ED. Again, it will be 4 squared plus 2 squared, which again, 4 squared is 16. 2 squared is 4. We add them together and we get rad 20 again. So yes, this is a parallelogram. Okay, so translate the point We're on to Chapter 9, transformations. To the right, so that means it's going to be our x, 2 units to the right, plus, because we're going in a positive direction, x plus 2. And our y is going to be 6 units up, which again is plus. So we're going to do 1 plus 2, comma, which will give us 3. And our y, which is negative 3 plus 6, which will give us 3. All right, rotate 3, negative 1, 180 degrees. Well, remember it was xy, and it becomes negative x, negative y. So we have negative 3 and 1. Counterclockwise, we have x, y, and that rule, x, and it becomes negative y, comma, x, which is negative 4, negative 2. And then when we reflect over the y-axis, x becomes opposite. So we're going to have negative 2, negative 7. And when we reflect over the x-axis, y becomes opposite. So we have negative 5 and negative 4 now. And when we reflect over the y equals x axis, they simply switch places. So it goes xy, and after that reflection, it becomes yx, which is negative 2, comma 3. And then lastly, y over negative x, you have your x and your y, and not only do they switch places, but they become opposites. So it becomes negative y, negative x, which, switching places, becomes a positive 4 and a positive 2. And lastly, our factoring. Okay, so no coefficient. I don't see a GCF, so I'm just going to do my straight up x factor, where 12 goes to the top and the middle brother comes to the bottom. Well, what multiplies to 12 and adds to 7 would be 3 and 4. Hooray! So I'm going to do x plus 3 in one and x plus 4 in another. Okay, again, I don't have a coefficient in front of my x. Well, I just have a 1, so I get to do x factor again. And my middle brother, negative 8, comes to the bottom, and negative 9 comes to the top. So what I'm going to do is do a negative 9 and a positive 1. Together, they multiply to negative 9, and they add to negative 8. So I have x minus 9 and x plus 1. Again, I don't see a coefficient, there's no number greater than 1 in front of my x squared. I'm going to do my x factor again, negative 30 on top, and middle brother, oh, there's a 1 there, so drop a 1. So that's going to be 6 and negative 5, because together they multiply to negative 30, but when you add them, they add to a positive 1. So I'll have x plus 6 and x minus 5. Okay, now I see a GCF. They're all divisible by 5. So out comes a 5. I have x squared minus 5x plus 6. And I'm going to put it into my x factor. So 6 is going to go on top, and negative 5 is going to come to the bottom. And it's going to be a negative 2 times a negative 3. So negative 2 times negative 3 is a positive 6. You add them and you get a negative 5. Well, I can't forget my GCF, so it's coming out over here on the answer. And now I'm just going to have x minus 2 in one bracket and x minus 3 in another bracket. Here again, I can see a GCF. They're all divisible by 2. So 2 comes out of the equation, and I'm left with x squared minus 8x minus 20. And I can do my x factor. So 20 at the top, negative 8 at the bottom, and I get a negative 10 and a positive 2. Together they multiply to negative 20. Whoops, sorry, I forgot the negative. And they add to negative 8. So my GCF would be out in front. I'd have x minus 10 and x plus 2. Okay, I have another GCF. So no, I don't. Just kidding. Okay, so I get a factor by grouping now. Okay, I'm going to multiply my first and my last term, and I'm going to get 36. And I'm going to bring my middle brother down to the bottom, which is negative 15. So when I go ahead and factor those, I get 12 and negative 12 and negative 3. So what I'm going to do is I'm going to take my first term, 2x squared, minus 12x, this 12, minus 3x plus 18. And then I'm going to factor by grouping. So I see that I can divide out a 2x, and I'll have x minus 6 left. And here I can divide out a negative 3. So minus 3, and I have x minus 6. My parentheses match. So I did it correctly. 2x minus 3 will be one parenthesis. And the matchy-matchy parentheses become 1, and it's x minus 6. Moving along, I look for a GCF. I don't see one. So I go ahead and I multiply my first and my last term. I get negative 24. And I bring down middle brother, which is 5. And I see that it's a positive 8 and a negative 3. I'm going to group it with my first term, 12x squared plus 8x minus 3x minus 2. 3x and minus 2. Again, factor by grouping, I see that they are both divisible by 4x. So 4x comes out. I'm left with 3x plus 2. And I look here, oh, there's nothing to divide out, but I can divide out a negative 1 because I want it to be 3x plus 2. So out comes a negative 1, 3x plus 2. All right, so my GCFs become one parenthesis, 4x minus 1. And then my matchy-matchies become another parenthesis, 3x plus 2. All right. Here I look and I see that there is no GCF. So I'm going to multiply the first and the last term again. This and this get multiplied. I have 36. I bring down my middle brother, which is negative 12. And a negative 6 and a negative 6 multiply to be a positive 36 and add to be a negative 12. So again, I do 9x squared. My first term, I bring it down. Minus 6x, this guy right here. Minus 6x, that guy right here. Plus 4. And I factor by grouping. So out comes a 3x. I'm left with 3x minus 2. And out comes a negative 2. Divide by, or negative 2. And 3x minus 2. In my parentheses, I have 3x minus 2 times 3x minus 2 as my answer. Some of you guys might write it as 3x minus 2 squared. That might sound more familiar to you. Okay, so here, two perfect squares separated by a subtraction sign. That's a difference of 2 squares. So the square root of x squared is simply x, and the square root of 4 is simply 2. So you're going to have x minus 2 in one parenthesis, and then x plus 2 in another set of parentheses. Same thing here, just a bit bigger. So the square root of 9x squared is 3x, and the square root of 25 is 5. So you would have 3x minus 5 in one parenthesis and 3x plus 5 in another. And there you go. There is your final bit of your study guide. Thanks, guys. Good luck.